Hello everyone. Note down this question. It's a cyclic process, A, B, C, back to A. This is T naught. This is 3 T naught. This is V naught. Find out work done by the system. Cyclic process starts from A, B, C, back to A. At A temperature is T naught, at C temperature is 3 T naught. This part is passing through origin. This is the vertical part, this is the horizontal part. Right at this point, volume is V naught. First tell me, can we find area of the triangle and will it give us work? Yes or no? If we calculate total area, then is it going to give us work done by the system? Good. The graph is between volume and temperature, and therefore we cannot use the concept of area. Concept of area is used when graph is between pressure and volume. So take the hint. Look at these three segments independently. Forget about this, consider this, then consider this, and you can easily find work. From A to B, what type of process do you see? From B to C, what is the process? And from C to A, what is the process? Identify this and you can answer the question. A to B, B to C, C to A. So answer this. What is A to B? What is this process A to B? Good. In VT graph, if graph passes through origin, then it represents an isobaric process. B to C. I hope you can see that. From B to C, this is temperature axis. Everywhere temperature is what? Constant. So it's an isothermal process. And C2A, volume is constant, and therefore it is an isochoric process. Now you already know how to find work for these three types of process, and find the work, get the total, that will be the total work. For the isobaric part A to B, work done is what? N R T final minus T initial. What is temperature at B? 3D naught. What is temperature at A? T naught. So this is NR T final minus T initial for the isobaric part. C2A is isochoric. Work will be 0 for the isochoric part. Now it's about B to C. What is B to C? It's an isothermal process. What is work done for an isothermal part? N R T. Which T? Temperature of the isothermal part. What is that? 3D naught. Log of V final upon V initial. V final from B to C as you arrive. What is volume at C? V naught. C is the final point, moving from B to C. What is volume at B? What is the AB part? AB part is the isobaric part. From A to B, if I use PV equals to nRT, then pressure is constant. And you can see that at A temperature is T naught, at B it becomes 3T naught. That means as you triple the temperature, this volume is also going to triple. So what is volume at B? 3V naught. Volume at point B. Now, log of V final. You're moving from B to C. This is initial, this is final. V final, V naught divided by V initial, 3V naught. So total work is coming NR 2T naught, and if you have the idea of log, this is 1 by 3. V naught cancel, which I can always write in this form. NR 3T naught log of 3. What I have done, this is V naught cancel, log 1 by 3. Log 1 by 3 is log 3 to the power minus 1, which is minus of log 3. This is work done by the system for the given graph. If you see a cyclic process, don't always go for the area. First, check graph is between P versus V or between some other quantity, and then solve the question. If you understand this question completely, then write down yes in the comment box. Write down molar specific heat capacity. Molar specific heat capacity. What is molar specific heat capacity? First of all, it is represented by C. Now, write down the definition of molar specific heat capacity, and then everything will be clear. Amount of heat required to change the temperature of unit moles by unit degree Celsius is called molar specific heat capacity. It's called molar specific heat capacity of a gas. Amount of heat energy which you need to provide so that you can change, let's say, raise temperature of 1 mole of a gas by 1 degree Celsius. That is called what? Molar specific heat capacity. Now, let me ask you a very basic thing first. If I say I'm increasing the temperature by 1 degree Celsius, then by what amount I am changing the temperature in Kelvin? Write down this in the comment box first. Let me see if you're conceptually good or not. If I raise the temperature by 1 degree Celsius, then by how much in Kelvin I am changing the temperature? Well, that's what I wanted to know. That's what I wanted to know. Well, I'll give you a hint. Let's see if you can answer with the help of hint. Let me repeat the question first. You are increasing the temperature of a system by 1 degree Celsius. If you use Kelvin scale, then by how much in Kelvin you are increasing the temperature? And your options are 1, 273, 274, 272. Which option is correct? A, B, C or D? किसी आदमी को पकड़ में नहीं आया. Correct answer is A. Think about it. I'm giving you 10 seconds before I answer this thing. Think about it. How come A is the correct thing? Now look here. Suppose initial temperature is 10 degrees Celsius. What is 10 degrees Celsius? Everybody knows 10 plus 273 Kelvin. An increment of 1 degree Celsius means what? 11. What is 11 in Kelvin? 11 plus 273. So what is this? 283 Kelvin. What is this? 284 Kelvin. What is delta T? T final minus T initial. What is T final minus T initial in terms of Celsius? 11 minus 10, which is what? 1. In terms of Kelvin, 284 minus 283. That is also what? 1. Now remember this. What is that which you need to remember? Temperature, when you convert it from degree Celsius into Kelvin, you need to add what? 273 temperature wise. But change wise, 1 degree Celsius is only what? 1 Kelvin. So when I say you are increasing temperature of a gas by 1 degree Celsius, by how much in Kelvin you are increasing the temperature? Again, by 1 Kelvin only. You're not increasing the temperature by 273 plus 1. No, it's only what? 1 Kelvin. Do you understand this part? Yes or no? Write down the statement. Change 1 degree Celsius is same as 1 Kelvin. Change wise 1 degree Celsius is same as 1 Kelvin. So, we're talking about C, and what is C? Amount of heat required to change the temperature by 1 degree Celsius, and if you have been given 1 mole of it. But it was not possible to find 1 mole, we found n moles. It was not possible to change temperature by 1 degree Celsius. We changed it by delta T, and in the process we gave it delta Q heat. We can also use dt and dq. So what this says, n moles of a gas, temperature is changed, let's say increased, is delta T, and for that heat supplied is delta Q. Using these things, who can get me C? What is C in terms of N, delta T and delta Q? Write down fast in the comment box. Good. Look here. N moles, temperature is raised by delta T and heat supplied is what? Delta Q. For N moles you are supplying delta Q heat. For unit moles, delta Q divided by N. For N moles, temperature is raised delta T, heat supplied will be delta Q upon N. Now again, for 1 mole, when you increase the temperature by delta T, you have to supply delta Q upon N. And therefore, for 1 mole, if you change the temperature by 1, heat supplied will be delta Q upon N delta T. That's your C. dQ upon N dt. So what is molar specific heat capacity? dQ divided by N dt. What is the unit of molar specific heat capacity? Joules per degree mole per Kelvin or per degree Celsius. Both are same. Joules per mole per degree Celsius or Kelvin. You can use whatever you want. This is the formula for C. Remember this. Note down this, and then if you remember what I meant with adiabatic process, we discussed adiabatic process a little bit in the previous class. So what is molar specific heat capacity for an adiabatic process? Look at the formula. Answer this in the comment box. Good. For an adiabatic process, dQ, heat supplied, this is basically what? 0. If your dQ part is 0, then what is C? 0. A short answer type question. What is molar specific heat capacity for an adiabatic process? 0. You're not supplying any heat. If you're not supplying any heat, automatically it becomes what? 0. But write down this as a statement also. For an adiabatic process, molar specific heat capacity is 0. Molar specific heat capacity is 0. Now tell me, what is C for an isothermal process? Write down in the comment box, what is C for an isothermal process? Well, there are two ways of answering this. One is infinite and the other is not defined. Both are correct depending on the question, we can take C for an isothermal process in infinite, and that will give us a correct numerical value. Things like 1 upon infinity can be made 0. And not defined, this is also correct. How come? Look here. Infinite is very much clear once you look at this part, delta Q upon N delta T. It's an isothermal process and therefore delta T. There is no change in temperature, 0. Anything upon 0 is what? Infinite. So this must be clear to everyone. Now let's discuss not defined. How do you define C? For C, statement is that you need to increase the temperature by 1 degree Celsius. So if I say that I have to increase the temperature by 1 degree Celsius, on the other hand I am saying that I need to keep temperature constant throughout, then both these things cannot take place simultaneously. You cannot increase the temperature by 1, at the same time you can keep the temperature constant. No. These two things are not possible, and therefore we also say that C is not defined. Let's understand C infinite with the help of a second argument. Suppose you have a container. There is a piston and you are supplying heat to this container, and temperature is T, and it was asked that you need to measure what? C. So what you did? You're supplying heat and hoping that its temperature is going to increase. But suppose somebody is here, another person, and he has been told that somehow or anyhow you have to keep temperature of this container constant. So this guy always keeps temperature of the container constant, but this, the one who is supplying the heat, he doesn't know this. So what we need from this? C. What is the definition? Supply heat so that temperature increases by 1 degree Celsius. So in the hope of that temperature one day will increase by 1, he just keeps on supplying heat to the container, but temperature doesn't increase because this guy's responsibility is that all the time temperature should remain what? Same. So what happens? जैसे जैसे ये हीट सप्लाई करता जा रहा है, इसका हीट काउंट कहां पहुंच रहा है? इनफाइनाइट. टेम्परेचर से उम्मीद है कि कभी बढ़ेगा, बट ऐसा कभी हो नहीं पाया. फॉर हिम C is what? Infinite. This guy, he says what? I've been told that temperature should not increase. If temperature should not increase, then how come you can ask me that raise the temperature by 1 degree Celsius so that I can find C? No, I cannot, because I've been told that temperature of the container should never increase. For him, it's not defined. For him, it's what? Infinite. Note down this. With the first line, if you wish, you can write that n moles of a gas are supplied delta Q heat and temperature increases by delta T. This is the first line. And then things are easy. Now, the molar specific heat capacity, which is useful for us, they are obtained for isochoric process. For isochoric, C is called CV. CV. It means we are supplying heat at constant volume and temperature is increased by unit degree Celsius of unit moles. For isobaric, it has a name CP. So when you see CP, it means molar specific heat at constant pressure. You have a container, you supply the heat, you keep the pressure constant always, amount of heat transferred so that temperature increases by 1 for unit mole. This number will be what? CP. At constant volume, if you do this, the number will be called what? CV. CP and CV, these are the things we are interested in, and let's see how do we develop CP and CV. We'll start with isochoric. Thermodynamics first law is dq equals to du plus dw. And we are interested in the isochoric part first. So what is C? CV. What is CV? dq upon n dt. C has the name of CV, which is dq upon n dt. This and this, it becomes n CV dt. This part, n CV dt equals to du plus dw, which is 0. Isochoric volume is constant. dw becomes what? 0. Concept of molar specific heat capacity gives us that du is NCV dt or U is NCV T. In the very first lecture of thermodynamics, I told you that internal energy of a system depends on its temperature. This is the relationship between internal energy and temperature. I hope you remember that statement that when temperature increases, internal energy increases. When temperature decreases, internal energy decreases. So, internal energy is something which depends on the temperature. This is the function. U equals to N CV multiplied by T. We have found formula for U with the help of isochoric, but for any type of process, du is always NCV dt and U is always NCV T. What does it mean when I say that for every type of process? You will understand that once we go and see the isobaric part. But as of now, note down this much first. write down the statement. Internal energy of a system, internal energy of a system depends upon its temperature and is given by U equals to NCVT. It is given by U equals to NCVT. Next line. Although we have developed the formula for with the help of an isochoric process, it is valid for any type of process. It is valid for any type of process. What does it mean? Suppose somebody told you that U is a function of temperature. It means that U is something which depends upon what? Temperature. You thought that if it's a function of temperature, then there will be some constant. Let's say that constant is A and there will be temperature present. A simple version is this. Internal energy is a function of temperature. Very elementary definition is that U is something, some constant, let's say 2, 3, 4, 5, 6, a number, and a term for the temperature. We had no idea what this A is. Isochoric process, it tells us that A is basically N multiplied by CV, and slowly we'll get inside CV also, and you already know number of moles, and we'll see what basically CV is. So far we have found what? This constant A. What A basically is? N multiplied by CV. What is CV? 5, 6, 7, 3 or some number. We'll see that later. Now let's use the concept of C for an isobaric process now. When you use it for the isobaric one, dq, for any type of process, dq is always what? du plus dw. If it's an isobaric process, then dq upon n dt has a special name, which is what? Cp. This and this. What is dq? N Cp dt. N Cp dt. What is du? For any type of process whatsoever, du is always N Cv dt. N Cv dt. Now look here, it's an isobaric process. Any type of process, internal energy is a function of temperature. There is some constant 2. Just for the time being, let's say internal energy is 2T. Internal energy depends only on what? Temperature. What type of process it is, it has nothing to do with it. It's an isothermal, isochoric, adiabatic, any type of process. internal energy if temperature is T will be 2T. Suppose. So if it's an isobaric one, you will be using what? 2T. If it's an isothermal, you'll be using 2T. Isochoric, you'll be using 2T. To find this number 2, we have used the process of what? Isochoric, and we found that number 2 is basically N into Cv. I hope it's clear that how come du is this. Now, what is dW? It's an isobaric process. For isobaric process, dW in terms of temperature is what? Nr T final minus T initial. You remember that? Nr T final minus T initial. What is T final minus T initial? dt. This is dW. dt, dt, dt. Cancelled. N cancelled. We got Cp equals to Cv plus R, which is Cp minus Cv equals to R. This is called Mayer's formula. Mayer's formula. Difference of molar specific heat capacity at constant pressure and at constant volume is always a constant, and that constant is what? R. You've got a new definition for R. Cp minus Cv, R. It's an important result. This is the derivation. This relation is called Mayer's formula, and we'll try to feel the Cp minus Cv part, but first note down this much, and if you are comfortable with this derivation, then write down yes in the comment box. Now look at the feeling part. There are two identical containers having identical gases, exactly same number of moles. Let's say 1 mole of hydrogen. Volume, temperature, pressure, everything is same initially. For this one, you need to supply some heat and you have to make sure that pressure remains constant. For this, you need to supply some heat and you have to make sure that volume remains constant. And your aim is what? That for both delta T is 1. Delta T is 1. Look, you've got unit moles inside. 1 mole, hydrogen, hydrogen, everything is same. Initial setup. I told you that keep the pressure constant in the first vessel and container and supply some heat so that temperature increases by 1 degree Celsius. This is 1, this is already 1. You know that this dq then will be nothing but Cp. Your N is 1, dt is 1, and therefore Cp is directly what? dq. Simple understanding. Over here, again, 1 mole, temperature कितना बढ़ाना है अपने को 1, जो हमने हीट सप्लाई की, उस हीट सप्लाई डी क्यू, इसका नाम क्या बन गया? सीवी। तो दोनों केस में अब हमने क्या करना है? हीट सप्लाई करनी है, एंड वी वांटेड टू फील this Cp and this Cv. Tell me first, किस सेटअप में चेंज इन इंटरनल एनर्जी ज्यादा होगा? Write down fast in the comment box. For the isobaric container or for the isochoric container, for which container there will be more change in the internal energy? For which one? While taking too long, only one response, and that response is correct. Change in internal energy will be same, because internal energy has nothing to do with whether you keep pressure constant or you keep volume constant. You are increasing the temperature by 1, you are increasing the temperature by 1, that means change in internal energy du is same. तो भाई इंटरनल एनर्जी का चेंज क्या कर दिया? सेम अपन ने। लेकिन जो भी आप हीट सप्लाई करते हो, ये दो जगह जाती है। एक तो ये इंटरनल एनर्जी को बढ़ा देती है, और दूसरा सिस्टम क्या करता है? वर्क। Volume is constant. This piston does not move at all. Pressure is constant. Piston moves and occupies this new position. So in this case, when you supply heat, it is being used in two parts. One is changing the internal energy, and the second part is what? That does some work. So you gave 100. Out of 100, 80 goes for what? Change in internal energy, and 20 goes for work. So you gave 100, and this 100 is what? 80 and 20. यहां पर मैंने आपसे बोला जो भी आपने dq दिया था वो केवल किस में जाएगा? इंटरनल एनर्जी के चेंज में। एंड व्हाट इज दैट? 80। व्हाट इज द वर्क पार्ट? 0। इसका मतलब यहां पर Cv कितना है? 80। यहां का हीट सप्लाई कितना है? 80। यहां का dq कितना है? Cp कितना है? 100। When you talk about Cp and Cv, that's the reason Cp is always greater than Cv. Write down like this. Cp is greater than Cv. Hopefully you understand this thing. If you do not, no worries. Remember, Cp minus Cv is what? R, and Cp is greater than Cv. Although it's not that difficult. Go down this much first. One of you is asking that please explain the 80-20 part again. Well, you've got two pockets. One pocket is called delta U and the other pocket is called delta W, work done. And if somebody gives you some money, then you keep that money in delta U pocket and the other part of that in the delta W pocket. तुम्हारे साथ में एक तुम्हारा फ्रेंड भी है, तुम्हारा क्लोन, बेसिकली द आइडेंटिकल वर्जन। सो जब भी आपको कुछ पैसा दिया गया एंड यू बीइंग टोल्ड दैट चेंज टेम्परेचर का करना है 1, तुम्हारा इंटरनल एनर्जी काउंट 1 डिग्री सेल्सियस इंक्रीज करना है। इसका मतलब जो तुम्हारी वर्थ है वो इक्वल बढ़नी चाहिए। तो आपने क्या किया कि आपने, इस आदमी के पास 2 पॉकेट है, दूसरे आदमी के पास भी दो पॉकेट है भाई। इस पॉकेट का नाम है इंटरनल एनर्जी पॉकेट, इस पॉकेट का नाम है वर्क डन, इसका नाम है इंटरनल एनर्जी पॉकेट, इसका नाम है वर्क। नाउ if I say that for both change in temperature is 1 degree Celsius, 1 degree Celsius, this increases what? Their internal energy. Internal energy only depends on what temperature. तो suppose आपने 80 रुपीज देने थे, 80 रुपीज देने थे इस पॉकेट में रखने के लिए। रुपीज मीन्स जूल्स, बेसिकली रिलेट करते रहना। तो आपसे बोला गया यार 1 डिग्री सेल्सियस बढ़ाओ, 1 डिग्री सेल्सियस बढ़ाओ, 80 जूल यहां देना पड़ा। ये जो आदमी ये बोलता है कि कीप द वॉल्यूम पार्ट कांस्टेंट, डोंट चेंज इट। ये बोलता है कि कीप द प्रेशर पार्ट कांस्टेंट। मैंने बोला ठीक है, अगर ये वॉल्यूम पार्ट कांस्टेंट बोलता है इसका मतलब इसकी ये वाली पॉकेट बंद है। You cannot put any money in this pocket. It's closed. Volume is constant. इसका मतलब आपने इस आदमी को कितना पैसा दिया। कोई आपसे पूछता कि भाई बताना यार तुमने कितनी हीट सप्लाई करी है, क्यों? तो आप बोलते यार इसकी एक पॉकेट तो बंद है, केवल एक ही पॉकेट में एनर्जी सप्लाई कर पाया मैं, कितनी? 80। कौन सी पॉकेट है ये? कांस्टेंट वॉल्यूम वाले आदमी की। कांस्टेंट वॉल्यूम वाले आदमी को अपन ने क्या बोला हुआ था? CV। ये जो आदमी था इसने बोला कि जब आप मुझे 1 डिग्री टेम्परेचर बढ़ाने को बोलोगे, इन दैट प्रोसेस piston is going to move. You cannot say that you will give me 80 rupees only and my temperature will increase by 1 degree Celsius. In the process, when you give me some heat to change my temperature by 1 degree Celsius, I will do some work. And how much work it does? It does a work of 20 joules. इस आदमी के साथ कहानी ये है कि भैया आप 80 रुपीज दोगे, I cannot take 80 only, क्योंकि मुझे पिस्टन भी मूव कराना है। अगर आप पिस्टन मूव कराओगे, उसने बोला कि in that process I do a work of 20. So if you want to increase the temperature by 1 degree Celsius, you have to give him 80 as well as 20. This is what 100 constant pressure पर है, इसका नाम क्या है? CP. That's the reason CP is always greater than CV. कैच क्या है? ध्यान रखना, दोनों के हमने क्या बोला था कि तुम्हारी हीट, तुमको हीट देंगे और अपना इंटरनल एनर्जी काउंट बढ़ा लो 1 डिग्री सेल्सियस से। दोनों हैप्पी हैं। उन्होंने बोला हाँ 80 दे दो। लेकिन इस आदमी के साथ एक प्रॉब्लम है कि जब आप इसको एनर्जी सप्लाई करते हो टेम्परेचर बढ़ाने के लिए, उस प्रोसेस में पिस्टन के मूवमेंट की वजह से ये काम भी करता है। एंड बिकॉज ऑफ दैट he needs more money. More money means CP is greater than CV. I hope it's clear now. Now, look at this adiabatic process. Adiabatic process. Now, if you remember, I told you that relation between pressure and volume for an adiabatic process is PV gamma equals to constant. I gave you a brief idea of adiabatic process, and there I also told you that this gamma is greater than 1. Now, we are going to develop this formula using thermodynamics. Derivation will not be asked in your school examinations, remember. But the process will help you a lot. The way questions are solved, the way all the things which we have so far done in thermodynamics, how to use those things, you will learn with the help of this derivation. So if you do not understand, if you do not remember every step, no worries. But understand the process the way this format is developed. बहुत easy है, देखना. We have to develop relation between pressure and volume with the help of thermodynamics. So let's use dq as what? du plus dw. Now, it's an adiabatic process. What is dq? 0. Suppose for some other type of process, let's say they say that energy supplied is a function of temperature 3T, then you will be using 3T type of thing here. That will give us a different type of function between P and V. Right now we have been told that a process where no heat transfer is done is called an adiabatic process. That means dq is 0. What is du? For any type of process whatsoever, it is ncv dt. What is dw? जो हमने एडियाबैटिक प्रोसेस में वर्क निकाला था वो यूज नहीं करना है. क्यों नहीं करना है? क्योंकि वहां अपन ने क्या अज्यूम किया हुआ था दैट वी हैव पीवी गामा इक्वल्स टू कांस्टेंट. फिर हमने इंटीग्रेट करके वर्क निकाला था which was coming nRT final minus T initial upon 1 minus gamma. Last class में अपन ने किया था. But so far we have no idea of this, and therefore what is dW? For any type of process, dW is always what? PdV. केवल देखना. At the end you can take the screenshot easily. देखते हैं ना fast. dq is 0, du for any type of process ncv dt pdv. Now there are three types of variables present: t, p and v, and we want to find a relation between p and v. We have to eliminate this t. Now how do you eliminate this t? You will learn and basically revise so many things which we have already done before. PV equals to nRT. Let's differentiate this. How do you differentiate this? This is the differentiation. हमने क्या सीख लिया? प्रोडक्ट फंक्शन का डिफरेंशिएशन कैसे करते हैं ये रिवाइज हो गया. फर्स्ट फंक्शन डिफरेंशिएशन ऑफ सेकंड प्लस सेकंड फंक्शन डिफरेंशिएशन ऑफ फर्स्ट एंड आर दीज आर कांस्टेंट t dt. आपको लग रहा होगा ये कैसा डिफरेंशिएशन है? सपोज पूरी चीज आप x के रिस्पेक्ट में डिफरेंशिएट कर रहे हो. dx the term of dx is present everywhere. So what is first function p? Differentiation of v, dv upon dx. Differentiation of y with respect to x is what? Dy upon dx. Differentiation of v is what? Dv upon dx. Second function differentiation of p, dp by dx. nr t dt by dx. dx cancel and you get things in the black. फायदा क्या हुआ? We have got nr dt in terms of p and v. And why do we need nr dt? Because this is n dt. इसके पास चलते हैं अब. 0 cv n dt. What is n dt? What is n dt? p dv plus v dp. p dv plus v dp whole divided by r. This gives us n dt, and then cv plus p dv. p, v. If we can integrate this whole thing, we'll get this. If we can integrate this function, we'll arrive at this. Physics खत्म यहाँ पर. अब यहाँ से maths है. And I've told you that nobody is going to ask you this derivation. चीज क्या थी? Thermodynamics. Thermodynamics ने क्या बताया? dq is 0, du is this, dw is this. Differentiate, put it inside. अब ये चीज क्या बनी हुई है? And how do you integrate this part? देखना फास्ट इसको. ये क्या लिखा हुआ है? Let's take pdv common. pdv. Then you get 1 plus cv upon r. pdv, cv upon r, pdv. थोड़ी देर पहले इससे हम मुलाकात कर चुके हैं इस पूरी चीज से. क्या है सोचना, एंड देन मैं अभी यहां पर प्रेजेंट करूंगा इसको. एंड द नेक्स्ट थिंग इज योर cv डिवाइडेड बाय r into vdp. Now what is this? Mayer's formula, cp minus cv. It is what? R. So what is cp? cp is r plus cv. ये क्या लिखा हुआ है? r plus cv. एक स्टेप बचा लेते हैं ना. I hope you can see that this is r plus cv whole divided by r, which means this is pdv r plus cv. R plus cv is your cp divided by r plus cv divided by r into vdp. This side it's 0. Well, I will take 5 minutes more. So those who have another class, they can leave and then you can see the derivation later on. And those who can continue, look at this again. 1 plus cv upon r, simple maths है. r को यहाँ multiply किया, r plus cv. What is r plus cv? r plus cv is cb divided by r. Then next thing is what? r, this is 0. I hope itni maths aati hogi. r cancelled. Once this whole thing is cancelled, you get what? Look at this. This is p dv cp that side minus. On this side you've got cv v dp. p dv cp that side, cv v dp this side. But you cannot integrate this part as of now. For integration, same type of variable should be present on same side. This is p, this is dp, this is v, this is dv. So let's do what? Let's transfer same variables on the same side. This becomes then dv divided by v cp divided by cv with a negative sign equals to, hopefully आपने ये part note कर लिया होगा. And if you have not, just don't worry, I'll give you the lecture. So, what is this? dv divided by v, cp divided by cv, keep the negative sign. On this side you've got dp divided by p. And we need to integrate this whole thing and this whole thing. Everybody knows what is the integration of dx upon x. What is the integration of dx upon x? We found this thing in the last class only. Dx upon x, integration is what? Log p. Look here, minus of Cp upon Cv. What you are left with? dV upon V. dV upon V. What is the integration of dV upon V? Log V. Plus some constant of integration. Whenever we integrate, we use what? Constant of integration. Normally we write that constant as C, but right now let's not use C because C is used for molar heat capacity. So let's say K. Now what we did, it's a constant. If it is a constant, why not use log K? It's our wish. If I say 2 is a constant, then log 2 is also constant. So since every term is in terms of ln, the constant of integration term, we have taken that as ln k. Even if you take it as k, you will arrive at this. You will. Just for simplicity, we have taken ln k. Now what is the whole part? This whole thing is now this is minus of Cp upon Cv ln P. One step fast, ln P, shift this thing there. It is ln of V to the power Cp upon Cv. फ्यूज ना उड़ गया हो आपका, माइनस Cp upon Cv, इसको इधर शिफ्ट किया, it becomes what? Plus. Then Cp upon Cv as a coefficient can be transferred as the power. This is coming from log. पूरा डेरिवेशन क्या करवा रहा है? लॉग का रिवीजन. इसको इधर शिफ्ट करने का तरीका, माइनस इधर गया प्लस Cp upon Cv as the power plus log k is what? 0. अब यहाँ hopefully this is done. I hope you know that log a plus log b plus log c. In log, when you write log a plus log b plus log c, what does it give you? This is the product formula for log. So what you have in front of you is log of p into v to the power Cp upon Cv multiplied by k is 0. अगर मैथ्स नहीं आती तो फिर डेरिवेशन किसी काम का नहीं है. एक तरह से मैथ्स का रिवीजन हो रहा है जो अपन लोगों ने बिल्कुल लेक्चर्स के स्टार्टिंग में काइनेमेटिक्स के पहले किया था. log a plus log b plus log c is what? Log a into b into c. So that's what you got. Now what is that number whose log is 0? What is that number? That number is what? 1. So what do you got? P v to the power Cp upon Cv into k as 1. Log of 1 is 0. So this number is what? 1. If this number is 1, then if this number is 1, then it tells us last 2 minutes, in fact 1 minute only, Cp upon Cv is 1 upon k. But what is 1 upon k? What is k? I told you that k is a constant. So if k is a constant, then 1 upon k is also what? Constant. Cp upon Cv, this power in short is written as what? Gamma. What is gamma? Cp upon Cv. And it's called what? adiabatic gas constant. Cp upon Cv. Cp is a constant, Cv is a constant. इतना बड़ा बंडल Cp upon Cv का हमने शॉर्ट में से क्या बोलना शुरू कर दिया? गामा. तो moment you call it gamma, what do you got? PV gamma is constant. What is gamma? Cp upon Cv. But you know that Cp is always greater than Cv. If Cp is always greater than Cv, then gamma will be greater than 1. Nobody is going to ask you this complete derivation in school, but I hope you can see the beauty of the derivation. कैसे thermodynamics use हो रही है, कैसे maths use हो रही है, differentiation use हो रहा है, log use हो रहा है. ये profile इस तरह का है that it gives you a good feeling of physics. शायद आपको मेरे चेहरे पर happiness feel हो रही हो कि when I teach you things like these, तो ज़्यादा मजा आता है कि कैसे हम फिजिक्स को बेसिक्स को अगर स्ट्रांग रखेंगे तो हैंडल कर सकते हैं. And if you do not understand anything, don't worry. Remember what? PV gamma is a constant, gamma is greater than 1. That's all. If you understand the derivation, 70-80%, and if you think that by looking at the lecture again you can understand everything, if you are 80-90% comfortable, then write down yours in the comment box and then you can leave. Thank you very much.